Hey Geometry, I'm trying to squeeze in one more video before my kids bug me to death about taking them fishing. So today we're talking about section 10.4. We're going to be learning about some angle relationships that are formed in circles by some very specific lines. First thing we're going to do is take a look at the picture. Maybe not the clearest picture, but it is a picture of a bridge that's in Portugal. And it is a pretty cool bridge if you ask me, because there's a road down here, but there's also a road at the top. So very neat how it has two different roads on it. So the upper road, the first question says, what does the upper road represent? Well, for us, that's going to represent a tangent. Remember that a tangent is only going to touch the circle at one point. Now, realistically, that road up there is going to touch that bridge at more than one point, but just based off of the way it looks, we're saying that it looks like how a tangent would look. Now, what about this line right down here? And this is another vocabulary word from the beginning of the chapter, but that one is going to be a secant. Now, you might have thought chord, and I can understand that. Remember, a chord is going to go from one side of the circle to the other. But the reason that we're not calling this a chord and we're calling it a secant is because a secant will continue to keep going. It doesn't just go from one edge of the circle to the other. It's going to go past the circle, which is what that road is going to do. There would be no point to have a road right there that only goes from this edge to this edge. Obviously, the cars want to keep going in one direction or the other. So tangent is a line that is touching the circle at just one point. A secant is a line that is touching the circle at exactly 2 points, and it's going to continue to go in both directions. So let's talk about this first theorem. This one says if a tangent and a secant slash chord intersect on the circle, then the measure of each angle formed is 1/2 of the measure of its intercepted arc. So this one is very similar to an inscribed angle. Remember, we just talked about inscribed angles in the last video. We said that an inscribed angle is half the measure of its intercepted arc. So same thing happens right here. If you have a tangent and a secant, or a tangent and a chord, and they are intersecting directly on the circle, then the arc that they intercept, the angle is 1/2 of the arc. So in this particular picture, this angle TCA, would be half of the measure of this arc, whereas this angle on the other side would be half of the measure of its intercepted arc. So if it's if the vertex is on the circle, it's going to be equal to half of the intercepted arc. And here's what it means by on the circle. There's the vertex. So that vertex, point C, for both of those angles is directly on the circle. All right, so the next theorem says if two chords or secants intersect in the interior of a circle. So this time their vertex is not on the circle, but their vertex is inside of the circle. Then the measure of an angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. That's very wordy, isn't it? So let me show you what this means. Let's suppose that we were talking about angle 3 and angle 1. All right, we're gonna take their arcs that they intercepted, so those two arcs right there that they're intercepted, we're going to add them together, and then we're going to chop that value in half. So we're still dealing with the half, but we are adding the two arcs that they intercept together. Same thing happens if we were going to look at angle 2 and angle 4. So here's angle 2 and angle 4. They're intercepting different arcs. So again, you would take those two arcs, you would add them together, and then you would take that value and you would chop it in half. So if they intersect inside of the circle, you're going to take the intercepted arcs, add them together, and then chop that in half. All right, we have a different scenario for this next theorem. So we're talking about either having two secants, which is what we see here in this first picture, or we might have a secant and a tangent. Remember, the secant touches the circle at 2 points, the tangent touches the circle at only 1 point, or maybe we have two tangents. So both of those are touching the circle at exactly 1 point. But for all of these cases, the vertex is the exterior of the circle. So it's outside of the circle. So angle A is outside of the circle. Angle D is outside of the circle. Angle H is outside of the circle. So this time we're dealing with a vertex that is outside of the circle. Then it says that the measure of the angle formed is 1/2. So we're still dealing with 1/2. The positive difference of the measures of the intercepted arcs. Here's what that means. That means that instead of adding, we're now subtracting. But your order is important because when you subtract, you want to have a positive difference. So in other words, that means that you need to take the bigger arc and subtract the smaller arc from it. So if we take a look at this example right here for case 1, CT is the bigger arc, BR is the smaller arc. That's why we did CT minus BR, bigger minus smaller. Same thing's gonna happen over here. FG is the bigger arc, EG is the smaller arc. Same thing's happening over here. IXJ is the big arc, IJ is the small arc. So every single time, if the vertex is on the outside of the circle, you're gonna do 1/2 times big arc minus small arc. So let's put all of these together. We're gonna make a summary for ourselves. So what happens if the vertex is on the circle? You're gonna do 1/2 of the arc. So whatever the arc measurement is, you're going to take half of it. What's gonna happen if your vertex is inside the circle? You're still gonna do 1/2, but you're gonna take your two arcs. I'm just calling them arc 1 and arc 2. Doesn't matter which one's bigger or smaller. And you're going to add them together before you take half of it. And then lastly, if your vertex is on the outside of the circle, we're still gonna do 1/2. This time we're gonna do subtraction, but remember with subtraction, it's important that your difference is positive. So you have to have your big arc going first, and then you're going to subtract the smaller arc from that, and then take your 1/2. So if you can know these three things, you don't need to know all those theorems word for word. This is what their theorems are telling you. So if you can know those three things, then these problems will be pretty easy. So let's take a look at example number 1. We're being asked for letter A to find angle PRT. So here's PRT. Notice that R is on the circle. So we're gonna be using this first one right here. 1/2 of the arc. So we're gonna do 1/2 of 152 degrees, and we're going to be left with 76 degrees. That's gonna be our angle measure for PRT. Now let's look at part B. We want to find the measure of RST, which is that right there. And that would actually be pretty easy, right? Because we know that the entire circle is what? 360 degrees. So we're gonna take the 360 degrees, we're gonna subtract away the 152 that's on the other side already, and that's gonna leave us with a measurement of 208. So that one is pretty easy to come up with. All right, example 2, here we go. First, we wanna find the measure of angle DKB. So we are looking for this angle right here. So let's look. That angle is a vertical angle from this angle, and they are intercepting those two arcs. Now let's look at where the vertex is. It's inside of the circle. So remember we said we were going to do 1/2 of the sum of the two intercepted arcs. So we have a 60-degree arc and an 80-degree arc, and we want the sum of that. So if you add 60 and 80, you get 140, and half of 140 is 70. So our missing angle right there for both of them is 70 degrees. All right, letter B, we want to find the measure of angle AKD, which is right here. Now, what's the relationship between DKB and DKA? You remember those make a linear pair. That means they have to add up to 180 degrees. So if this one is 70 degrees, if we subtract 70 away from 180, we are left with 110. So that one is pretty easy if you can remember those relationships that we've been learning about all year long. All right, example 3. Where is the vertex? Vertex is right here. It's occurring outside of the circle. Remember, this is where you're going to do 1/2 of the big arc minus the small arc. All right, well, let's go back to our picture. According to the picture, the big arc is 190. The smaller arc is 60. So if we subtract 190 minus 60, that leaves us with 130. And half of 130 is going to be 65 degrees. So our angle measure there is 65 degrees. All right, example 4. We have several kinds of angles occurring here. Let's look at what we have. They told us that the measure of arc BE is 100 and the measure of arc AR is 25, and that's already in your picture. So number 1, we want to find the measure of angle number 1. Okay, well, where is the vertex of angle number 1? It is outside of the circle. So remember, that means that your angle measure is equal to 1/2 times your big arc minus your small arc. All right, so angle 1 is going to be equal to 1/2 of, the big arc is 100, the small arc is 25. 100 minus 25 is 75. And what would half of 75 be? It would be 37.5 or 37.5. So angle 1 is 37.5 degrees. All right, angle 2. Where is the vertex? It is on the circle. So that means angle equals 1/2 of its intercepted arc. All right, so angle 2, right here, there's the arc that it's intercepting. So it's going to be 1/2 of 25, and half of 25 is 12.5 or 12.5. All right, letter C, we're looking for angle 3. Let's see, angle 3 is right here. All right, and angle 3, that vertex is on the circle. So same thing that we just saw in letter B. The angle equals 1/2 of the arc. What's the arc that it intercepts? It is intercepting this 100-degree arc, and half of 100 is 50 degrees. So angle 3 is 50 degrees. All right, example number 5. So the measure of arc AB is 120. The measure of arc BC is 30. The measure of arc CD is 160. They're asking us to find the measure of angle Q. So the vertex for angle Q is outside of the circle. So again, this is where we're going to have that the angle is equal to 1/2 of the big arc minus the small arc. Well, if we look at the picture, we definitely have information about one of those, right? So here's angle Q. It's intercepting this arc right here and this arc right here. We have the small arc is 30. We don't have the big arc. So here's where we have to do a little bit of calculations, because we know that a circle is 360 degrees. So far we have 120, 30, and 160, which gives us 310 degrees so far. So how many degrees are we missing? We're missing 50. So my guess is this picture is probably not quite drawn to scale, because that definitely looks bigger than 50, but that's okay. All right, so we're going to do 1/2 of the big arc, which we just said is 50, minus the small arc, which we found out is 30. 50 minus 30 is 20, and 1/2 of 20 is 10. So 10 degrees is the measure of angle Q. So really it all boils down to you guys knowing those 3 formulas. All right, example 6 says use circle K to find the value of x. So our goal is just to solve for x. So let's look at what we have. We have an angle right here. It's intercepting 2 arcs. This is the big one, and this is the small one. And the vertex is outside of the circle. So again, angle equals 1/2 of the big arc minus the small arc. All right, so the angle measure we actually know right here, x plus 2.5. So I'm going to plug that in place of the angle. Then I have the 1/2. Now I'm going to come to my formula. The big arc is 4x plus 5. And now I'm going to subtract the small arc, which according to my picture is 50. So I have x plus 2.5 equals 1/2 times, I'm going to go ahead and combine like terms there. So I'm going to get 4x minus 45. All right, if you feel comfortable with decimals or fractions, we can go ahead and distribute that 0.5. So I'm going to distribute. So 1/2 of 4 is 2. And 1/2 of 45 is 22.5. Now, if you don't feel comfortable with decimals or fractions, what could you do? You could multiply both sides by 2. That would allow you to get rid of that fraction, and it would actually get rid of that decimal. But if you're comfortable with decimals, why not? All right, so now I'm subtracting x from both sides. So I have 2.5 equals x minus 22.5. And the last thing that I'm going to do is add 22.5 over. And I'm running out of room, but that's okay. I'm going to get that x is 25. And let's go back and make sure we're answering the question. It just said solve for x, so yeah, we're definitely done. All right, last example. This is a pretty easy lesson, I think. All right, it says use circle S to find the value of y. So if you look at where the angle is, its vertex is outside of the circle. So again, we're using the same formula. Angle equals 1/2 times the big arc minus the small arc. We have a problem though. So in the picture, we know what the angle is and we know what the small arc is, but we know nothing about the big arc. And one of the problems is this isn't even a number, right? So let's talk about it. If this were y, what could you write down about this side over here? Well, we know that a circle is 360 degrees. So if I knew what that number was, I would subtract it from 360. That would make sense because that would give me what's left over. Well, I'm going to do the same thing, except I'm going to have a variable. So I'm going to have 360 minus y. That's going to be the value of the big arc. So here we go. In place of angle, I'm going to put the 28. Then I have the 1/2. In place of the big arc, I'm going to put 360 minus y. So that has turned into that. And then behind it, I'm going to put minus the small arc, which means just minus y. So let's combine like terms in the parentheses. We would get 360 minus 2y. And you got the 1/2 out there still. And now I'm going to take that 1/2 and distribute it right here. So 1/2 of 360 is 180. And 1/2 of 2y is 1y. So now I'm going to subtract the 180 over. And so I need to know what is 28 minus 180. I'm going to start writing over here because I'm running out of room. That would be negative 152. But on the other side, I have a negative y, and we don't want a negative y. So we're going to divide both sides by -1, and we get that y is 152. Let's make sure we've answered the question. Find the value of y. That's all they asked us to do. So we know that y is 152. So really, for this particular section, everything just boils down to you guys knowing those 3 things. If you can remember those 3 formulas, then this section is a piece of cake. So that's it for this lesson. And tomorrow, hang on, let's see. So this video is for Thursday, although it is not Thursday, it is Tuesday for me. But the video is for Thursday. And then tomorrow I'll have the Zoom session at noon. What I would encourage you to do is to start the review packet before 12 tomorrow, so that if you have questions, you can get on the Zoom session at 12 and be able to ask me those questions, because I would love for you guys to have an opportunity to ask for help, because your assignment over the weekend is to complete a quiz and get that back to me by 5 p.m. on Sunday. So I would really like to be able to answer any questions that you have. And that can be questions over that packet, but it can also be questions over the worksheets that you've either done for 10.3 or 10.4. So definitely, I would love to see most of you on Friday for that Zoom session. So I hope that you'll show up. And if not, then I'll see you at the next one.